Hello everyone, Nadezhda here, and in today's lesson we are going to learn how to create the model of the topography. We are modeling it using simply the AutoCAD file, and you're going to be using this method a lot whenever you have the AutoCAD file that doesn't have any of the 3D geometry in it, and that is basically very often. So let's go through this method as well. It is a method that is a little bit slower and it does require a little bit more work, but sometimes it's going to be necessary for you to do that because you don't always get the perfect site plans. Sometimes you get the site plans that lacks a geometry, doesn't have any 3D lines in it, so you are going to need to model the topography from such files as well. First, I'm going to go to the Insert option and go to Link CAD to link my site plan. I'm going to be using the same site plan as in the previous lesson where we had the generating from the 3D, but this time I'm not going to be generating from the file. I'm only going to use this file as a reference to model on. This is how the file looks, and before linking, the only thing you have to check is which units are used. I'm going to click UN in my AutoCAD file, and as you can see, this file is unitless. That means I'm going to first be checking the units that were used for the drawing of this file, and then I'm going to set that up in my Revit file. So first I use the measure tool. I go to the distance and I'm just going to check some kind of distance to see what units were used for it. And I see here I have 1.5, so that means the meters were used because this looks like 1.5 meters. So here in my Revit file, I am just first going to choose the meters as import units. And by the way, it doesn't matter which units are set up in the CAD file. What matters is actually which units were used for its drawing. Even if you had the centimeters, for example, in the units option in AutoCAD, you are still going to set meters up here. Auto detect doesn't work unless your CAD file is perfect, and unfortunately that isn't very often. So I'm going to set up meters here, and everything else in this case is unimportant. I click open and I have my file linked. In the description below, I will add the link of the video of how to generate the terrain automatically from CAD file, but today I'm going to explain how to use this file and model the terrain by hand. This file does have 3D geometry in it, so we are going to be using it only to check whether our model geometry is correct, because obviously if it is correct, it is going to fit well within this model. The first thing we do is go to the Massing and Site tool and we go to the Toposolid. I'm going to use Create from Sketch option, and first I'm going to create the boundaries of my terrain. I am just going to use this Pick Lines tool and I'm going to pick the lines of my terrain. I'm simply going to pick one plot because this is a giant file and I don't have time to create the entirety of it. That would take a lot of time, so I'm just going to choose one plot and I'm modeling that one plot. I have picked those lines. I also choose Trim Extent options to make sure that I don't have any gaps or any overlapping lines. Once I have created the boundary, I click Finish Edit Mod. Once I select it, I can see that I have modeled the flat terrain. I can go to 3D and I can see that this is what it looks like now. I have modeled the boundaries of it and it's flat, but now I have to add it some heights. Now, in order to model the heights, I can check out this file and I can see that it basically have brown isohypses and it has orange isohypses. And when I zoom in, I can see, for example, that this brown line is at height of 336 meters and the next brown is 338 meters. So there is 2 meters of difference in height between the brown lines. And since we have 3 orange lines in between them, that means that each line is half of a meter apart in height difference. So that means essentially I just have to apply the height that is written in each of the lines. And to do that, I first click on my Toposolid and I go to the option Modify Sub-Elements. In order to add the heights, we are going to be using Add Point option. This tool basically allows you to assign the height to the point. And I'm just first going to click Add Point, and I'm just going to add the points to my isohypses. I'm also going to be very mindful to be adding the points to the boundaries as well, so our boundaries do not retain the 0 height, but they also get their points. And basically you can first type in height in this option and then click on the points, but what I have noticed in modeling many of these terrains is that the faster way is simply first adding the 0 points height. You just assign the 0 heights, you add the points to entirety of your drawing, and then later you assign the heights. I don't know if that is the correct way, but I have found out that it does cut my time a little bit, it is a little bit faster, so this is the way I use it. Of course, you try some different options and you find out what works for you the best. So I just added the heights. I make sure that first I add it to the boundary line, so later on I can assign the point to that boundary as well. And then I keep adding the points everywhere along the isohypses. What I have to say is that the more points you add, the more precise your geometry is going to be. Because if I were to, for example, add just 1 point to this isohyps, or isohyps, I'm not sure how it's pronounced on English, but if you were to just add few points and not many of them, you would get a little bit rough and edgy geometry. You would not get these smooth curves, but you would get a little bit sharper edges. And that means essentially you do need a little bit more points. Of course, the problem is the more points you have, obviously the more work you have to invest in this. So essentially you just choose how you're going to be drafting it. I'm just going to be adding it something like this. I think that's enough for me, but you choose what you're going to do. And I'm just going to fast forward this. I'm not going to make you watch add the points to the entirety of my file. So see you when I'm done, I guess. And all the points are added. You can see how it looks like now. It basically is still a flat terrain, but it does have its points. And now the next step is adding the points of your topography. What I first have to add is that you shouldn't mind the units. What happens to me very often is I will not change my units. I will remain to be in millimeters, which is the default value, and I will keep adding these heights, which are in meters, and I would get a mess. This is something that happens to a lot of people. They will simply forget their units, and this is something that you should be very mindful of. Essentially, this height that I see here in these numbers is in meters, and as I said, I haven't still changed the unit of my file, and my file is now in millimeters. So you have two options. Now you can either convert your entire file to meters and then insert these units, and then simply once you are done you can convert it back. It is not like in AutoCAD that it will cause you any trouble. Changing the units in Revit is harmless. Or you can simply insert these numbers in millimeters. Me personally, I do like the option of converting the entire model to meters, because very often if I don't do that, I kind of start typing in the millimeters, and somewhere along the way I simply forget that I was doing that. So half of the file ends up being in millimeters and I just create a mess. So I will just go to manage to project units, and for a time being I will change the length to meters. I click OK, and I click OK once again, and now I can start inserting. But there is one more thing I should keep in mind, and I will go back to modify. My tool is still active, but if you have by accident simply gotten out of this Toposolid and you want to keep going, you simply click on it and you go to the modify sub elements option. This will get you back to the active tool and you can keep on doing this. What you should keep in mind before continuing is this elevation base option. As you can see, this 332 meters elevation is essentially survey point elevation. Project base point is basically the zero of your entire project, and we still haven't set that up. This is an empty file, so in this case it's correct to use survey point here because all of these values are survey point values. So I click here on survey point, and then I will select one of my points. I will start by this one, and I can see this brown line that is close to it. I will just trace the number of it, and I can see that is 328 meters. So that means this point is 328.5 meters. So I select it and I simply insert 328.5. I already forgot. I hope I insert it right. Click enter, and this is what we get. It is showing 329 because our precision is not set up. I will just go back to UN and I will set length to have 2 decimal places so I can see the actual value and not the circled one. Now I will do that for the next points. I will select all of these, and in the elevation option I will just insert 329 because this is by half meters higher. So I do that for each one of these. This is 329.5. Click enter, and as we do that, our elevations rise and we can see that we are making a progress in this file. We can also go to 3D to check what is going on, and I can see that my points are actually rising to catch this 3D geometry exactly. It is very helpful that we have this file where we can actually track the progress and we can actually see the proof that what we are doing is correct. So I go back and I do that for each of the lines. We are at the brown line again, and I can see that this one is 330, which is exactly half meters higher. And I'm not going to annoy you again with inserting each of these points. Basically, I will simply insert each point and I will simply fast forward and we can see how it looks in the end. By the way, halfway I have realized that these other layers and lines are confusing me. I get kind of confused what is my terrain line, what is some other random line. So I'm going to select this AutoCAD file and I'm going to click on Query. And I'm going to select these lines that I want to hide, and in this case it is this path that is causing me trouble. So I click on it and I can see its layer name here. So I can go to my visibility graphics option and I can go to imported categories option, find this file and find that layer. I will hide these two layers because they sort of overlap with my terrain lines and they sort of cause confusions to me, so I'm just going to hide them and click OK, and now they are not existing anymore. So I select once again, I go to Modify Sub-Elements tool once again, and now I keep adding my heights. By the way, this is how it looks so far. It looks nice. And soon we are going to finish everything else, so you will see how the terrain looks. I've added more lines and I see that I've got this weird moment here. So whenever you got these weird moments like some strange geometry showing up, that means that basically this point hasn't been assigned the value of height. So that means you should return to that point and add it the value, provided value. Of course, you can either add more points by using this add point option and simply checking in more points, or you can use this modify sub-element tool and delete points. You delete points by selecting them and clicking delete on your keyboard, and that way you can either delete this point so you don't have to add it value, or you can simply add it the height. Essentially, these strange geometries are indication that you have forgotten to add some pieces, but once you do that, you can go back and add the rest of the lines. I've inserted most of the points. I still have to insert these boundary ones. And for example, this one is somewhere in between 338.5 and 339. So I'm just going to insert some middle value, for example, 338.7. And that is going to be as close as it gets to the actual value. So you can do that whenever the point does not line exactly at the line. And I think this is it. I think this is everything. I go to 3D to check how it looks, and this is what it looks like. I can see that it fits perfectly to my terrain. I will hide the AutoCAD terrain. Oh, and I see that I have this one strange gap in the middle. I go to that place, I go again to modify sub-elements and I check what's wrong. This is 337.0. That means there's probably some point in the middle. Yeah, I can see this one doesn't have assigned value. I can find it in a plane and assign it the value, or I can delete it, which I will do in this case because that's the faster thing to do, and I can see what my geometry looks like. I click OK. I will also assign it the consistent colors option so we can see what it looks like fully in the 3D, and this is what it looks like. The reason why the soil is this high is because we still haven't set up our survey points, our project base points, nor everything else about this site. Basically, the survey point is by default 0, and our terrain is at around 300-400 meters high, so it is essentially reaching from these base points of 0 to somewhere around 300 meters height, and that is why it's this high. If we were to set up the elevation of our project right in the beginning, if we set up our survey heights, our project base heights, then we wouldn't have this giant amount of soil in the bottom, but that will be the topic of one of the next lessons, and I will post the video link in the description as soon as I post it. But this is how we model terrain in case we don't have the file which we can use to generate it automatically. Of course, if you have any questions, if you had any trouble during the process, please let me know. I will answer all of your questions in the comments below, and if you like my videos, subscribe and like. I post them every couple of days, so see you in the next lesson. Bye! If you want to learn Revit like a pro, take a look at my architectural course through the link below. You will learn how to develop the project from concept to final design using Autodesk Revit. It is ideal for beginners, but valuable for anyone looking to build a solid foundation. By the end, you'll know how to take a design from concept to detailed documentation with confidence and clarity. You will gain a solid Revit workflow you can actually use independently or in work in larger teams in architectural studios. With almost 100 structured video lessons, it is designed to help beginners master Revit step by step. To support your progress, I've included assignments with each lesson, plus the opportunity to ask questions and receive guidance directly from me whenever you need it. This way, you're not just watching tutorials, you're actively learning, practicing, and improving every step of the way. Thank you for watching, and see you in the next video.